There's a longer video on this, but just to sum it up in 1 minute, if you look at this at chi-squared goodness of fit test, there are 3 claims you could make about this population. You could say, I just think it's a normal distribution. And you're not saying what the mean is or what the standard deviation is. Or you could say, oh, I think the mean is 19. Or you could actually stipulate what you think the parameters are. And we can do a goodness of fit test in either situation. It's just in A and B, we will have to calculate the mean and standard deviation from the sample. Now, can you see that that's a weaker thing to say? Just to say it's a normal distribution compared to being specific. And that needs to manifest itself in the probability. And the way it does that is with the degrees of freedom. So every time you have to calculate a parameter based on a sample, you subtract another one off the degrees of freedom. So for this question C, if that's the claim being made, then the number of degrees of freedom is subtract the number of rows by 1 and the number of columns by 1. So that is 1, 2, 3, 4, 5. But if I had to calculate the mean from this data or the standard deviation, I knock another 1 off. And if I have to do both, then I knock 2 off. And that when you type that number of degrees of freedom into your calculator, it makes a big difference to the p-value. That's it. So have a look at this question. It is claimed that the number of earthquakes in Peru every year follows a Poisson distribution. So what is our distribution here? That effectively, what is the null hypothesis? Well, we don't know what the average is. We're just saying it's a distribution. So we have to calculate the average from this data. Let's do that on the calculator. So obviously you just type it in, calculate, you remember to press set. Yes, it's set correctly. 1 variable. So over 60 years I've counted how many earthquakes. 12 years they didn't have any at all. 25 years they had 1. So the average is 1.266. So that is a calculated one, so I must subtract 1 off the number of degrees of freedom. How many degrees of freedom are there here? Well, there were 3, because this 0 doesn't count. There were 3. That is n minus 1, r minus 1. Or rows minus 1, columns minus 1. That's 3, but I had to calculate that number. So that's 2. And then I can do a goodness of fit test. And just to remind you to do that, I'll go to menu down to distributions, Poisson. Well, I know that the average is 1.12666. What is the probability of getting 0? 28%. So I'm going to find 20% of 60 and put that as my expected number against 12. Then I'm going to go for 1. 35% of 60 and put that against 25 and then see how good the fit is.